Last class started a design problem. This is what given: one interior column load is 1.95 meganewton. So it consists of dead load plus live load, and there is one exterior wall. Load intensity is coming 85 kilonewton per meter. Generally in this type of design or all buildings, generally we provide 0.15 meter of your floor slab, and this soil consists of sand, and gamma is given 17.5 kilonewton per meter cube. Water table is located at a depth 2 meter below the ground surface. So there are two boreholes recording, borehole 1 and borehole 2, and n values has been given up to 5 meter depth. Now let us start this design. So first your n values to be corrected. So sigma prime or P prime above water table, which is equal to 17.5 into H, and it is below water table, which is equal to 17.5 into H minus 2 into 10, H minus 2 into 10. So below your water table, that would be fine. So put it in a tabular form: H in meter, P prime in kilonewton per meter square. Correction factor you can get it from IS code. Then borehole 1, in borehole 1 there is one n filled, then n corrected, then your n cumulative average, and second one is your borehole 2, again it is n actually filled, n corrected, then n cumulative average. So if I take it in a tabular form, that will give me idea. So H in meter, that is your 1 meter, 2 meter, 3, 4 and 5. P is equal to 17.5, for 2 is equal to 35.0. P prime is your overburden above water table and below water table, it has been calculated. Then 42.5, then 50.0, then 59.5. Correction factor is your 1.6, 1.35, 1.30, and it is your 1.20, and this will be 1.16, and field is your, which is given, that is your 16, 17, 19, 20, 18, and corrected 25.6, 22.95, 24.7, then 24.0, 20.88, and cumulative is your 25.6, then 24.08, 24.42, 24.31, then 23.63. Here it is 15, 18, 23 for borehole 2, 24 and it is 20, N corrected is your 24, 24.3, 29.9, 28.8 and it is 23.2, N cumulative is your 24, 24.15, 26.07, then is your 26.75, then it is your 26.04. Now, once you have taken the N cumulative, many books if you see, they assume the width of the foundation as an trial and error, but here it is not true. If this is the case, suppose for example, interior column is there, suppose there is a footing has to be provided, this is my load, I look at depth first below the ground surface at which my SPTN cumulative values are consistent. If you look at here between 2 to 4, here it is between cumulative average 3 to 5, we are getting almost equal values of N cumulative. Now, as foundation has to be provided, so minimum depth of the foundation generally provided, it varies from 0.5 to 1 meter. So, then we have to choose size of the footing in such a way that if this is B, this should be at least B, and within this zone the SPTN value should have higher value. What does it mean? That means it will take the load, because this is our load intensity within this zone, it will take entire load. Beyond this, it is not effective. So, that is the reason you can choose your footings either placing 2 meter, 3 meter or 4 meter below the ground surface, depending upon whether you are getting and size, so that the pressure intensity, your pressure intensity whatever it cover within this zone as well as within this zone. Here the values are quite consistent and same, it is 24.08, 24.42, 24.31, here it is 26.07, 26.75 and 26.04. This is the concept, no assumption about your foundation size as well as the depth. I will assume in such a way that my depth of the foundation, so that my width of the foundation I will take it, the pressure ball pressure intensity should come within this region as well as within this region. Let us start it. So, column footing, interior column footing. And the settlement is given, permissible settlement is your 25 mm, assuming settlement governs design. Why it is assuming settlement governs design? Because the permissible settlement is already given, it should not be more than 25 mm. So, Then you consider n is equal to 24 and h is equal to 4 height for borehole 1. Then in that case SPC, what is your SPC? SPC is your soil pressure settlement, considering settlement as the criteria. So then SPS is your 10.5 into N. 10.5 into N, it comes from here. ASP, allowable soil pressure, or SPS 10.5 N for 25 mm settlement, for 50 mm it is 21 N. Then it comes out to be 252 into 0.7 minus 0.7 to 0.8 water table. Some water table correction has to be taken. So here 191.52 kilonewton per meter square. So area, required area is your 1950 from where it has come? Here 1.95 meganewton. So 1950 Newton divided by 1950 kilonewton divided by 191.52. So this comes out to be 10.18 meter square. So then once it is 10.18 meter square area, then the size of the footing, size, let me take it 3.25 by 3.25, and which is your 10.56 meter square, which is greater than 10.18. 10.18 is your required area. So it is okay now. Now this 3.25 has to be put it. Size of the footing is your 3.25. At least here it should be 3.25. So if it is 3 it is up to given up to 5 meter. So 3.25. Let us see. So take the depth of the foundations. Depth of the foundation is equal to 0.6 meter. So then actual, what is the height you are getting? What is the h you are getting? 0.15. Where is your 0.15 coming? Slab, floor slab. 0.15 plus 0.6 depth of the foundations plus 3.25. 3.25 is your width, because then up to here this B, minimum B 3.25, then it is coming exactly at 4 meter for borehole 1. So consider that 4 meter is okay. 4 meter is okay with the size which has been identified, the complete size of the foundation, size, this is your 3.25 meter by 3.25 meter, and depth of the foundation is equal to 0.6 meter. This is your size, you got it. Then we have to check with this size whether this bearing capacity and settlements are coming within this permissible limit or not. With this size you have to check it. So then soil bearing pressure, so SBP, soil bearing pressure, is equal to gamma n gamma by 2 plus NQ minus 1 into dF by B. Let us take factor of safety is equal to 2.5 into B. So you can easily find it out for n is equal to 24. What is the value of NQ and n gamma? N is equal to 24, you can find it out what is the value of phi. Then from there you can find it out NQ and n gamma. So, this I leave it to you. You do it and check whether this calculation is correct or not. So, this comes out to be 255.15 kilonewton per meter square. Now, water table corrections. So, water table corrections has to be added. Water table corrections, Cw is equal to 0.5 plus 0.5 2 by 0.6 plus 0.15 plus 3.25, which is equal to 0.75. Here it is 0.5 plus 0.5 dW, water table is located at 2 meter, dF plus B, water table is located at 2 meter. So, it is here 0.5 plus 0.5 2 meter, dF 0.6 depth of the foundation plus floor slab 0.15 plus footing size 3.25, this is your 0.75. So, soil bearing pressure which is equal to 255.15 into 0.75, which comes out to be 191.36 kilonewton per meter square. Soil pressure considering settlement, which is your 191.52. So, generally minimum value you have to take it. So, minimum is your 191.36, hence bearing capacity is calculated as 191.36 kilonewton per meter square. This is what floor slab 0.15 and footing size is your 3.25 by 3.25 meter, and this is your 0.6 meter. So, this is your interior column. Now, net load intensity, let us see net load intensity. Net load intensity is equal to 1950 by 10.56. 10.56 is actual area. So, it is coming out to be 184.66 kilonewton per meter square, plus there is a concreting here. So, this has to be 0.6 plus 0.15, which is equal to this into 25, which is equal to 0.75 into 25. 25 is the concrete density. So, which comes out to be 18.75 kilonewton per meter square minus gamma dF, which is equal to 0.75 into 17.5, which comes out to be 13.125 kilonewton per meter square, which comes out to be 190.29 and which is less than 191.36 0.36 kilonewton per meter square. So, after checking it, now it is fine. It seems it will come out, to be fine because we have taken care of that pressure bulb. So, now final recommendation, adopt size 3.25 by 3.25 at a depth of 0.6 meter. Similarly, you can check for your wall footings. At the end of the wall footing, this is about your bearing capacity and settlement based on your 10.5 N values. At the end also you have to check also how much is your settlement. That has to check, even if it is 10.5 N considering 25 mm, you have to check once again. So, next part is your wall footing, exterior wall footing. Generally wall footing, these are walls coming, exterior wall, interior columns are there, outside exterior walls are there. So, load intensity on column footing, you can start with your load intensity is given how much, 85 kilonewton meter. Load intensity 85 by your bearing capacity 190.29, which is equal to 0.45 meter, then B is equal to 0.45 meter. Then take DF is equal to 1.2, then DF plus B, which is equal to 1.2 plus 0.45, 1.65, 1.65 less than dW water table, which is your 2 meter. Hence, your if it is less than water table, then correction factor is your correction factor per water table is equal to 1. So, at H is equal to 1.65, at H is equal to 1.65. So, borehole 2, generally what happened out of these two boreholes, if you look at here, the borehole 1 has been taken from the interior column, borehole 2 taken nearby is your exterior wall. Then BS2 N cumulative is equal to 24.1. So, considering B is equal to 0.45, dF by B is equal to 1.2 pi by 0.45, it comes out to be 1. So, soil bearing pressure is equal to gamma n gamma by 2 plus NQ minus 1 into dF by B 2.5 into B, which is equal to 155 kilonewton per meter square, which is less than 190.29. So, these things you calculate based on your N values, you can find it out NQ and N gamma and NQ, because based on your N values you can calculate is your phi, then NQ and N gamma. So, then you just change slightly, changing B is equal to 0.5, D is equal to 0.2 meter. So, your soil bearing pressure which is equal to 190 kilonewton per meter square. So, then net load intensity, you can very easily find it out. Net load intensity, net load intensity which is equal to 85, load coming into, then considering B is equal to 0.5 because it is a wall per meter length into 1 which is equal to 170.0 kilonewton per meter square. Then additional which is equal to 0.2 plus 0.15 into 25 minus 17.5 which is equal to 2.63 kilonewton per meter square, which comes out to be 172.63 less than 190. Then you adopt wall footing which is equal to 0.5 meter. So, if I summarize what we have done, this is the case has been given. One is your exterior wall, another is your interior wall, and it has been advised or it has been asked to design, particularly for the loading is given 1.95 mn and exterior wall is your 85 kilonewton per meter, and water table is located at 2 meter below the ground surface and it is a sandy soils, and there is a borehole 1. It has been, this borehole has been made and SPTN near the interior wall, and there is a borehole 2 near is a exterior wall. So, basically n value has been corrected. These are all field n values. So, Cn value are taken from BIS, Bureau of Indian Standard, the chart from there. So, with H, what is your overburden pressure? Cn. For borehole 1, n filled, n corrected and n cumulative. For borehole 2, n filled, n corrected and n cumulative. If you look at these two, basically we are identifying a depth at which the SPTN value is consistent and slightly higher. SPTN is consistent and slightly higher as compared to this. So, that if I can put a foundation in such a depth, so that entire pressure bulb passes through this, then your foundation is safe. In that case, considering this parameter, so we have started with the interior column footing and it is given 25 mm permissible settlement. This is your permissible settlement. So, then n is equal to 24, h is equal to 4 for borehole 1. Soil pressure considering settlement, it is 10.5 N. So, area is coming, size of the foundation is coming 3.25 and depth of the foundation we are putting at 0.6. So, that h is 0.15, this is my floor slab 0.6 plus 3.25, this is your 4. So, total size is coming 3.25 and 3.25, df is 0.6. Here there is no assumptions based on the SPT value. Then we cross check with your soil bearing pressure, water table corrections, and bearing capacity comes out to be 1.91.36. Then with this net load intensity has been calculated. Then we confirm that this size is fine, this size is fine. Similarly, wall footing size has been found out by 0.5 meter. This is how it started, how we have to proceed the design. Only one part I left it, that you can try, that is your settlement. Check the settlement whether it is coming below 25 mm or not, considering this footing size. That part I left, it will come. Next class I will go for footings in clay. I will stop it. Thank you.